Hello students, welcome to our channel Helm of Science. Today I will discuss a very important chapter of class 9 and it is structure of atom. Now before going into the chapter, we should at first know what is an atom. Now atom is the smallest constituent of an element, or you can say it is the building block of matter that is present around us. Now I hope you all have studied in class 8 that atom is made up of 3 subatomic particles. What are they? They are electrons, protons and neutrons. So we will start off with some important points regarding these 3 subatomic particles. So we will start off with electrons. So we can say electrons means what? They are a subatomic particle and it is negatively charged. It is negatively charged. Right? Negatively charged. Number 2, if we talk about the mass of an electron, it is very small and its value is, the mass is 9 into 10 to the power minus 28 gram. See, 10 to the power minus 28. That means it is a very small mass. Hence, in various calculations, we sort of ignore the value of the mass of electrons. Right? That means we ignore the mass of electrons regarding the calculations. And if we talk about the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. The C means coulomb. And remember, this charge is actually negative. Why? Because electrons are negatively charged particles. That means electrons carry 1.6 into 10 to the power minus 19 coulomb of negative charge. Okay. So this was, and one more point is electrons was discovered by J.J. Thomson. J.J. Thomson. So this scientist discovered or showed us about the existence of electrons within an atom. Right? Next we will move on to protons. Now protons, they are positively charged particles. Right? They are positively charged particles and protons were discovered by Eugene Goldstein. This won't come in exam, but I am just telling it for your knowledge. Eugene Goldstein. Right? So this scientist discovered, or rather showed, the existence of protons inside an atom. So the number one point is they are positively charged particle. Positively charged particles. And if we talk about the mass of one proton is how much? 1.6 into 10 to the power minus 24 grams. Right? So the mass of a proton is 1.6 into 10 to the power minus 24 grams. Again, it is a very small quantity, right? 10 to the power minus 24. And if we talk about the charge, then it is 1.6 into 10 to the power minus 19 coulomb. Now, you have to remember that as protons are positively charged particles, hence this charge is positive. That is, a plus sign will be there. That means it carries 1.6 into 10 to the power minus 19 coulomb of positive charge. Okay. Now we move on to the next type. Next type, that is neutrons. Neutrons. So neutrons, this was discovered by James Chadwick. James Chadwick showed the existence of neutrons inside an atom. Right? So neutrons, as the name suggests, they are neutral in nature. Neutral in nature. That means they do not carry any positive or negative charges. That means they are chargeless in simple terms. So they are neutral in nature, and if I talk about the mass, it is again 1.6 into 10 to the power minus 24 grams, a very small quantity. And what will be the charge? This charge will be 0. As I have told you that neutrons are neutral in nature, hence their charge is 0. That means they do not carry any type of charge. Now we will have to discuss about some models of atom, right? Thomson model of atom. Thomson model of atom. Now this scientist, that is Thomson, he proposed the structure of atom like that. The atom is basically, he considered it as a sphere containing a positively charged center, and the negatively charged electrons are embedded in this sphere, right? That means it contains a spherical positively charged center and it is surrounded by the negatively charged electrons. Okay, this was proposed by Sir Thomson in his model. Now this experiment, or rather this proposal, was unable to explain few results that carried out by other scientists, specifically Rutherfords scattering experiment. That experiment nullifies this concept. That means this concept was ultimately cancelled because it did not satisfy the results that we wanted. Next we will move on to Rutherford scattering experiment. Now, Sir Rutherford carried out a scattering experiment in order to determine the structure of atom, or regarding the properties of atom, right? So what he did in his experiments, that he took a gold foil, right? He took a gold foil and the alpha particles. Now what are alpha particles? See, alpha particles are nothing but helium 2 plus ions, right? Helium 2 plus ions. That is, alpha particles have +2 charge, and it carries 4 units of mass. So this comprises the alpha particles. Now the alpha particles were passed through this gold foil, right? Suppose this is a gold foil. After passing through this gold foil, what he observed, that there were some particles which are striking a screen. Here is a screen, a fluorescent sort of a screen, and these particles were hitting the screen without any deflection. That means these particles are undeflected alpha particles. That means they are hitting the screen without any sort of deflections. And in another set, what he observed, that some of the alpha particles were striking the screen with large deviations. That means with large angles, right? Some of the alpha particles were striking the screen with large deviations, though it is very small in number, but he observed few of them which are deflected in this manner at large angles. Now, a very few of them, suppose 1 in 20,000, among 20,000 alpha particles, there will be only one alpha particles which will be directly turning back towards its original path. That means it will not reach the screen and rather it will turn back to its original path, right? So he observed these three movements of alpha particles on hitting the gold foil. Now from this experiment he concluded three main points regarding atom. Number one is, as most of the alpha particles were hitting the screen without any deflection, that suggests that most of the space in an atom is empty. That means the space inside an atom is empty. That's why most of the alpha particles were hitting the screen without any deflection. Now in the second observation, what he noticed, that some of the particles were deflected at large angles. Now this implies that the atom consists of a centrally placed positive, not centrally placed, the atom consists of a positively charged center called nucleus, right? That means he concluded that inside an atom a positively charged center is present and it was termed as nucleus, right? And what about the third conclusion? The third conclusion that he concluded rather was what? He concluded that the nucleus of an atom is very small as compared to the size of the atom, and it was for this reason that some of the alpha particles were deflected, or rather turning backwards to their original path. So I can write here that the size of the nucleus is very small as compared to that of an atom, right? So these are the three conclusions which he obtained from this scattering experiment, the Rutherford scattering experiment. Next we will discuss about the nucleus of an atom. Nucleus of an atom. Now what is nucleus? Nucleus is a small positively charged center that is present in an atom, right? If I consider this as an atom, it consists of a positively charged center which is called the nucleus, right? This is called nucleus, and inside the nucleus, what are the subatomic particles that are present? The subatomic particles that are present is protons and neutrons. That is, protons and neutrons are present inside the nucleus of an atom, and there is a term that is called nucleons. What are they? Nucleons is actually the number of protons plus neutrons present inside an atom, present in an atom. The number of protons and neutrons that are present in an atom are together called nucleons. So, a nucleus is a positively charged center present inside the nucleus, and it consists of protons and neutrons, which are together called nucleons. Okay. Now, Rutherford proposed a model of atom. Rutherford's model of atom. Rutherford model of atom. Now, what did he tell in his model? See, Rutherford told that a nucleus consists of positively charged protons and neutrons, and electrons are surrounded and they are surrounded by the electrons, and the electrons, suppose this is the nucleus, and the electrons revolve around this circular paths. Okay, rapidly they are revolving around the nucleus in some circular paths, which he named as orbits. That is, the electrons revolve around the nucleus around these orbits, right? And he also said that an atom is electrically neutral. Why the atom is an electrically neutral? Because total number of protons, that is total number of positive charge, is equal to total number of negative charge. That means the number of protons present inside the nucleus of an atom will be equal to the total number of electrons that surrounds the nucleus. That is why the atom is electrically neutral in nature, right? Now, there is a sort of interaction, or there is a sort of attraction between the nucleus of an atom and the negatively charged electrons, and that attraction is called electrostatic attraction. Due to this electrostatic attraction, the electrons revolve around the nucleus, and these electrons are being attracted by the positively charged nucleus. We all know that positive and negative charge attracts each other, and due to these two different charges, that is the two positive and negative charges, there exists a type of electrostatic attraction that holds the electrons together inside the atom. Okay, and these circular paths he termed as orbits, which I have told. Now, if I consider an atom of hydrogen, right? So, if I consider the nucleus of hydrogen as this, okay, it consists of protons and neutrons, right? Nucleus consists of protons and neutrons, and as hydrogen H11, right? So it consists of single proton. So according to Rutherford's model, as the atom is electrically neutral in nature, so it will contain only one electron. So this electron will move in this circular path via or with the help of electrostatic interaction. Okay, attraction, electrostatic attraction. Due to this attraction, the electrons and nucleus are attracted towards each other, and this stabilizes the atom to some extent. Okay, now this model has some limitations. This model has some limitations. A drawback, you can say it as a drawback of Rutherford's model. Rutherfords model. Right. Rutherfords model failed to explain the stability of atom. That means the stability of an atom cannot be explained with the help of Rutherford's experiment or Rutherford's model. Why? See, if I consider this nucleus, and suppose the electron is revolving around this circular path. Okay, the electron is revolving around a circular path, right? Since the electron is moving, it continuously emits some radiation, and as a result of it, it loses some energy. Okay, it loses some energy, and if this electron loses its energy, then what will it do? Its speed will be reduced gradually. That means at the first round it travels via this path, and after losing some energy it will move through this path, and again it will come like this. It is losing its energy, and finally this electron will be into the nucleus, and in that way a nucleus might collapse. Okay, as a result the atom will be destroyed due to the loss of energy which the electron is facing while it is revolving around the nucleus. But in general it does not happen. That means the atom in reality is very stable in nature, and this sort of incident does not happen in reality. But according to his model, this experiment had this sort of a drawback. Okay, so he failed to explain the stability of an atom, but one scientist explained this stability of atom, and his name was Sir Niels Bohr, right? So we will now discuss about the Bohr's model of atom in order to determine the stability of atom. Now, Sir Niels Bohr explained the stability of atom with his model. That is Bohr's model of atom. Bohr's model of atom. Here he also stated that an atom consists of electrons, protons and neutrons. Now there is a slight difference, that he said that the protons and neutrons are present inside the nucleus, and the electrons revolve around the nucleus in certain circular paths which he termed as shells, orbits or shells. There is a new term which he added, was shells. Okay. So he named these different shells as shell number 1, shell number 2, shell number 3, or K, L, M shells. K, L, M, N, O, P and so on. Moving from inward to outwards, he named the shells as K, L, M, N, O, P and so on. These are the shell numbers. And there is a certain limit to the number of electrons which each shell can hold. Okay. Suppose for now I'm telling the number of electrons that the K shell can hold is 2. L is 8. M shell can hold a total of 18 electrons. N shell can hold a maximum of 32 electrons. In this way, he postulated or he proposed this type of values to as to how many electrons can be filled in a particular shell, right? So this was new to his model of atom, right? And each energy level is associated with a fixed amount of energy. That means K shell has a fixed amount of energy, L shell has a fixed amount of energy, M shell has a fixed amount of energy, so different shells have different type of energies. Now, if I consider K shell contains 2 electrons, these 2 electrons will have the same energy until and unless it jumps to this energy or to this energy, or this shell, I'm sorry. If this electron is moving from this shell to this shell, then its energy will change. Otherwise, this electron and this electron will possess same energy as they both are in the same shell. In this way, he explained the model of atom, and this entire model explains the stability of an atom. So, Bohr's model explains the stability of the atom, right? We will discuss about there is a formula as to the number of electrons, maximum number of electrons that a shell can hold, okay, in the next video. Now we will discuss about atomic number. Atomic number. It is represented by capital Z, right? Capital Z. Now what is atomic number? Atomic number is the number of protons present in the nucleus of an atom. That means atomic number, that is Z, is equal to number of protons present in the nucleus of an atom. So this is atomic number. If I say oxygen 16,8, this 8 is representing the atomic number of oxygen. So the oxygen has the atomic number of 8, right? So basically, atomic number gives us the total number of protons present in the nucleus of an atom, right? Next, we will discuss about mass number. What do we mean by mass number? Mass number. Mass number is represented by capital A. Mass number, that is A, is equal to total number of protons plus total number of neutrons. Suppose I am considering it as capital M, right? Total number of protons plus total number of neutrons. Now we have already discussed that the total number of protons is equal to what? Is equal to the atomic number. So we can substitute total number of protons by atomic number. So A is equal to atomic number, that is Z, plus N. So here comes a relation between mass number and atomic number, right? So what is atomic number? Atomic number is the sum of the total number of protons, that is atomic number, and the total number of neutrons present in the nucleus of an atom. So this is the required relation between mass number and atomic number, right? Now if I tell you oxygen 16,8, so I'm just telling you, I'm telling an atom can be representation of an atom. How to represent an atom? An atom, if I consider an atom X, it is represented as A and this is Z. This is mass number and this is atomic number. Okay. So if I consider an oxygen, right? Oxygen. So how to represent this oxygen? We are writing 16 and 8. That means 16 is the mass number of oxygen, mass number, and 8 is the atomic number. So if I tell you that what will be the number of neutrons present in the atom of oxygen, what will be your answer? See, you can find out the number of neutrons from this relation. We have A is equal to Z plus N. So therefore N will be equal to A minus Z. So A is how? What? 16. 16 minus Z is equal to 8. So 16 minus 8 becomes 8. So we can say that the number of neutrons is 8 for oxygen atom. Okay. Now, if I tell you Cl3517. In Cl3517, how many neutrons are present in this case? So for this case, how many neutrons? N is equal to A minus Z. So A is 35 and Z is 17. So 18 will be the value of N. So in case of Cl3517, 18 neutrons are present. So in this way, we can determine the number of neutrons, or we can assign the atomic number and mass number of an element, right? So this was all about mass number and atomic number. So that's all for today. In the next class, we will discuss about the arrangement of electrons in the atom and also about the valence electrons and valency. If you find the video useful, then please like and subscribe to our channel Helm of Science for more videos. Until we meet in the next video, keep studying and take care of yourselves. Thank you so much.